Hi, this is Mr. Wang. Today, we are going to explore a fascinating red-face cube investigation, which will help us understand how patterns can be modeled using Boolean, quadratic, and cubic relationships. Let's get started. First, let me explain the vocabulary I'm going to use. I'll use the word block for the individual small cubic unit, and I'll use the word cube for the cubic structures made from these blocks. Then I'll use the side length, for example, that's 2, 3, 4, or 10 to differentiate these cubic structures. So I will call them cubes made from the side length of like this one is 10, 4. So the first cube is a block, as it is 1 by 1 by 1. The second one is 2 by 2 by 2, and there are 8 blocks to make up this cube. The third one is 3 by 3 by 3, and so on. Now, the surface of each of these cubes are painted in red, and just the surface are painted, so the inside are not painted. Then, when we dismantle the cubic structure into individual blocks, we group them based on how many of their faces are painted or colored in red. Then we counted the numbers and we aim to find a pattern, then make a conjecture. So the first cube is a very special one, as we can see that all the 6 faces are painted in red color. So we put it aside. So this investigation, we start with when the side length is 2. Now, when the side length is 2 units long, and there are, of course, 8 blocks, and each block has 3 faces painted in red, and all of the blocks are of the corner position. So we have 8 corner blocks in total, and each one has 3 red faces. Now, if the side length increased by 1, so it's a 3 by 3 by 3 cube, then how many corner blocks in total? That's right, still 8 blocks, because the corner position will not increase, so it remains the same as the increase of the size of the cube. But now we also have 6 blocks with just 1 red face. That is right in the middle. Just 1 red face. And we have 12 blocks with 2 red faces. That is at each side, right? 2 red faces. And we have 1 block right in the center, which is not colored at all. So this one, the center one, has no color. Let me just group them for you. So there are 6 blocks with 1 red face, 12 blocks with 2 red faces. We have 1 block with 0 red face, and the corner blocks, the 8 corner blocks are there. All right. Let's record the data. Now, imagine if now the side length is 4. Will the number of corner blocks still be 8? Yes, absolutely, because the corner position will never change, always be 8. So 8 3 red faces. What about the one red face block? And these are located right in the center of each faces of the larger cube. On each face, there are 4 such blocks. Can you tell me how many faces in total for this larger cube? You are right. So there are 6 lots of 4, which is 24 one red face blocks. Now think about the 2 red face blocks. These are found along the edges, right in the center of the edges, not at the corner. When the side length is 4, 2 red blocks are found, or we color 2 blocks right in the middle of each of the edge. Now, how many edges in total for a cube? Excellent. So there are 12 lots of 2, which is 24 two red face blocks. Finally, the 0 red face blocks are buried inside the larger cube, forming a smaller cube at the center. So for a 4-unit long cube, if we remove the outer layer, what is the side length of the inner cube? Excellent, it's 4 because 4, so when the side length is 4, we minus 1, so minus the 2 sides. Inside cube is a 2 by 2 by 2 one. So there are 8 blocks inside with no red color at all. Now, could you please copy the data in the table we have so far obtained? Then use the pattern to work out the red faces for the side length is 5. Then 2 of your chosen side lengths. Then 10, 100, and finally, you need to use a formula, develop a formula to find the number of faces for an unknown variable n. So n represents any of the natural counting number which is bigger than 2. Okay, thank you very much.